Next speaker is Alejandra Castro with the diet composition of the butterfly ray in western coast of the Gulf of California, Baja California Sur, Mexico. Okay, Alejandra.
Hello. Okay. Okay, so good afternoon. Gymnura marmorata, known as the California butterfly ray, belongs to the Gymnuridae family and is a benthic species that can only be found in the Pacific East between Point Conception in California to Mexico, including the Gulf of California. The species can be found essentially inshore in sandy bays, beaches, and over intertidal zone to a depth of 150 meters. The IUCN has classified the species as near-threatened. Gymnura marmorata represent one of the baited species that are highly commercial in Mexico by artisanal fishery and is a subject to intensive fishing. The California butterfly ray is the fourth most frequent caught in Mexico, and the principal capture to Baja California Sur represented the 43% of the total landing of baited in the region. Knowing the trophy dynamic of this species is very important. The reason is that this helps us to understand the relationship and the energy flow in the area where they inhabit. To understand better the mechanism, the aim to this study was to determine the feeding habit of Gymnura marmorata in the western coast of the Gulf of California. Using the stomach content, we also aim to identify the main prey items in the diet, calculate the trophic niche wide, and determine the trophic level. Sample: Gymnura marmorata specimens were obtained for fishing ground of La Dársena and San Bruno on the east coast of Baja California. The sample was carried out between August 2019 to February 2020. The rays were identified, measured, separated by size and sex. An abdominal incision was made to remove their stomach. The stomach were placed in plastic bags and transported to the laboratory to be frozen before the analysis. The stomach samples were frozen, and according to the category proposed by Stiller and Kohler, was determined the degree of fullness. This table represents the percentage. The stomach was open and the contents were classified by different groups of prey items. Then they were counted by categories and weighted. All the preys were classified by the degree prey digestion according to Galvan. The prey items were identified to the lowest possible taxon based on the degree of digestion that we use different taxonomic case. For the analysis, with the Shannon-Winner index plotted against the total number of the stomach sample to determine the minimal sample size of the stomach required to validate this study. Stomach content were analyzed using standard metrics based on the numerical, frequency occurrence, and gravimetric method proposed by Ellipse. The index of relative importance was computed following Pincus, and also to describe better the diet of Gymnura, we used the prey-specific index of relative importance following by Brown. The trophic niche wide was estimated using two methods, the Levin index and the graphical analysis of feeding strategy at Munzer. And the trophic level in Gymnura was done by using the Cortez estimate for this predator. Results. A total of 59 stomachs were analyzed for this study. 58 were immature and just one belonged to mature individual. The maturity was determined by the size of the white disc that is here in the slide. And the female represents a major of the samples with almost 89% of the stomach, beside male just represented 10% of the samples. Meanwhile, from these 59 stomachs, 37 had food and 22 were empty. Most of the stomach with food had a fullness degree of 1, were represented by 32 stomach. Also, the stomach counter generally were found in advanced digestion degree, like otholites or part of exoskeletal. We used 37 stomach to describe the diet. The number of the stomach were sufficient to describe the general species, the Atari starting in 33 stomach. All the Gymnura analysis consumed 18 prey items, as follows as 12 teleastes, 4 crustacean, 1 plantile, and unidentified organic matter. A total of 46 prey were analyzed. The ERI and the PSERI identified fishes remain and unidentified organic matter, which was the most important prey in their diet. Also, the grunt family, the Pacific sardine and the Latin grunt, have the main role in the diet of Gymnura. Ramirez and Rodriguez also found that teleostis remain were their principal diet, agreeing with the above. Also explained by the high level of digestion degree, process of digestion, and some other factor may affect the result, also explaining the big content of unidentified organic matter. Also, Gymnura marmorata has a very characteristic buccal apparatus that consists in a big mandibular area with pointed cusp at teeth, allowing to capture fishes complemented using suction. All these factors may help to accelerate the digestion process, making the crushing prey go to the stomach. Following event in 2017, the enzymatic action and the stomach acid could act faster, having as a result a loss of fishes remains and unidentified organic matter. The trophic niche wide estimate by Levin index was 0.22. This result expressed that Gymnura marmorata has a specialized diet. On the other hand, with the Amundsen graphical confirmed the specialized feeding strategy. However, most of the prey points were positioned throughout the upper left corner of the graph. Individual predators of Gymnura had an specialized on different teleostis prey. The specialization of the diet for teleost is consistent with previous studies. Nevertheless, the trophic niche is wide, but by individual, allowing to have a great selectivity in different species of teleost. The trophic level of Gymnura marmorata was estimated as 3.9, which is a typical secondary predator. This presented a little difference between the past studies, where the result was 4.1 to 4.2. They reported the species as a tertiary consumer. Our 3.9 could be influence of the unidentified organic matter was included in the calculation. Following Everett and Bizarro, rays that have size under 100 centimeters are denominated secondary predator. This could be considered because the size of individual in this study were between 23 to 76 centimeters. Gymnura has an important role because it's a secondary consumer that feed on prey that present high trophic level that are between 33.5 to 4. Okay, and an acknowledgement. Thank you to Dr. Galvan for all the help during the project. Also, thank you to Instituto Politécnico Nacional, Cicimar, Proyecto de TIburones&Rayas, la Universidad del Bosque, for all the support. Also, thank you to Dr. Arturo Tripp, Dr. Catherine Soto, and the biologist Mariana Alejandra for their patient teaching and guidance during the process and development of the project. And thank you for all the people that were part of this project. Thank you.
Walter, feel free to start your presentation.
Okay, thank you. Well, good afternoon. My name is Walter. I will introduce my master research project called Habitat Suitability of the whale shark breeding ground typos in the Eastern tropical Pacific Ocean. Just a brief introduction about the species which I work at. The whale shark is, as you know, one of the most emblematic sharks in the world. It's according for the big size that he can reach. There's the record that of some sharks can measure more 19 meters. And another important characteristic about the shark is that it's a filter feeding, is one of the filters feeding Slamobranch. He most of the time feeds plantimonous organisms, as euphasids and fish larvae. This animal have a circumtropical distribution. He rather prefer to be close to warm temperature regions around the world in waters goes from 18 degrees until 28 degrees Celsius. There's also a lot of work who shows that they present as size and sex segregations, where normally the adults, individuals are a little bit more far away from the coast in pelagic zones, while the juveniles normally are more close to the shore. This could be because, well, according to the physiology in the different stage of life of the animal. About the actual state of conservation of the animal, he is categorized as endangered species according to the International Union for Conservation. In the Pacific Ocean, it's not a commercial interest, but he could be a part of the incidental fisheries, which is a problem for these species. But the fisheries are not the only problem that the whale shark have. They also present another trends as the main threat: collision with vessels, habitat loss, pollution, and climate change. The last one, climate change, is one that in the last decade has been talking a lot of, especially for the problem that can represent to the sharks. In the case of the whale shark, there's a work from Cicimar and collaborators in 2014, when they make a prediction and they realize that the increase of the temperature of the water for the climate change in the future can make the habitat of the whale shark change. That means that the sharks will be in the face of new threats. In this map, I would like to show you all the movement of the sharks around the world. And if we pay attention in the Pacific zone, we can find a clear example about how they can migrate to very pelagic zones. And normally in the Pacific, there is a lot of national parks and marine reserves where they are protected. But once that they go far away from these protected zones, they can be catch for the incidental fisheries, and they can, they're gonna be more danger for them. So that's why these kind of works can support the tools to give more knowledge about the measures that we need to conserve the animal. According to what I told you before, my objective of the principal aim of my investigation is create models model the fundamental niche of the whale shark in the whole Eastern tropical Pacific using maximum entropy models. Specifically, what I want to do is describe the suitability habitat of each site that I will analyze, and compare it and work with the different environmental variables that describe how the whale shark distributed around the world. How this is being done, we are using satellite data. For that, what we did was tagging the sharks. We put this tag spot 6 and splash tag in the dorsal fin of the shark. Once that the shark get close to the surface, these tags send a signal to the satellite that is passing by. And in the future, we can download this information in order to get the longitude and latitude where the shark was detected. Until now, we have 15 sharks tagged from expeditions that Migramar did from 2011 to 2019. In a total, we have 3,601 detentions in all this period. And we also, for run Maxen, we need environmental variables. In this case, I'm using the environmental variables that describe better the distribution of the shark according to the biography that's already in the internet. No? And for create the model, we are using Maxen. Maxen is once that we both I have my occurrence data and the environmental variable data. The next step is to model this information. This will be done through Maxen. Maxen is a tool that uses a maximum entropy approach to estimate the probability of presence of a species or a phenomenon. This program uses non-present points and explanatory variables in raster from provide estimation of the presence in animals in a study area. Although Maxen has his own user interface, we will make use of their computer system to develop the models. And thanks to the package Quen, which allows us to bring Maxen to our interface. And well, now I'm in the middle of my research. For the moment, I only can show you my preliminary results. So it's important to mention that until now, I'm only using data for 2011 and 2012, because it's the data where there's more detections. And until now, I decide to split every year in 2 seasons. We have the cold season and the warm season. So the cold season coming from July and to December, and the warm season to the Pacific area is from January to June. This split was made according to the biography that exists and the stationability of the area. As you can see in this map could be confused as the temperature map, but the real thing is that the red points show us the high probability to find the sharks in all this zone, in all this area. And the white point has the occurrence data that the model used to train the model, Maxent used to train in the model, and the purple data is the data that Maxent used to test the model. And in the cold season, we can see how the identity of habitat change a little bit and goes a little bit more to the south. And that could be because normally in cold season, the presence of the Panama current will be more close to the equatorial tropical Pacific. And in the warm season, the shark normally go to the south to find more cold waters, thanks to the cold current of the Humboldt. Is what I have until now. I just want to say thank you to the different institutions that are supporting the project. And thank you to the Aquarium of Seattle for giving us this space to show the investigation. Thank you very much.
Okay, thank you, Walter. The next speaker is Elena Tamburin with the presentation, how to stay together, habitat used for the 3 sympatric sharks on the coast of the Baja California Sur, Mexico.
Hello to everyone. Can you hear me well?
Yes.
Okay. As Felipe told, my name is Elena, and I want to show you some results about some stabilized topic research that was focused about the habitat use of 3 sympatric sharks in the Baja California Sur in Mexico. It's not working. Now it's working. Okay. As we all know, shark can use different habitat, and the same habitat can be used for multiple species at the same time, which means that normally these species are not just coexisting, but they create a community, and they can actively use the different resources like space, or for example, feeding resources in different way. The resource partitioning is the most common explanation that has been proposed to decrease the competition between species, but this is not the only way, and this is not the only option, because there are some habitats that offer high degree of resources, like for example the coastal area, or in particular the nursery area, that in a lot of cases offer a high abundance of prey, especially from the young sharks. But also these animals, these habitats, are also the ones that sustain the most intense fishery activities. So this exposes the juvenile sharks to intense fishery pressure and mortality. And for this is critical, is imperative to identify this habitat, but also to understand how the different species can select the different habitat and can use this habitat in the same way. This is something that, for example, happens for 3 species like the Mustelus californicus, the shortfin majo, and the Spirna cigaena in the coast of the Baja California Sur. They share this habitat, they coexist in there, and they also represent a very important and valuable resource for the local fisheries. So it's important to understand why they select these places, how they can stay together indeed, also because for the future management, and also for their conservation, but also for the local fishermen. So our work was focused to investigate the trophic ecologies of these species and their habitat use and their habitat characteristics, and we chose to do this with stable isotope and trace element of selenium, cadmium, and mercury in hepatic and muscular tissue. We chose to use these components because these components are acquired throughout diet. And this means that they are that the chemical profile of this component depends from the distribution of the sharks and from the feeding strategies and the resource used. So they can give us some information about the ecological niche and the habitat preference of these species. As we said, we collect these samples in the Baja California Sur, precisely in the area of Las Barrancas. That is a very pristine area. The main anthropogenic activity is the artisanal fishery, but this area has also some ecological variability in mercury and in cadmium because it has some geological source of these both elements. We collect the samples of the three species, and we collect for all the individual muscular and hepatic tissue. And then we decide to apply a part of the normal statistic. We decide to calculate trophic position and also to apply the Sieber that estimated the niche isotopic, the niche isotopic and using stable isotope, but we also apply this analysis to the trace element to see if we can have like an insight in their ecology. So as the first results, as you can see, they have a very similar isotopic composition. We don't find any statistical difference between the nitrogen level of the three species. Indeed, our values for the Mustelus californicus were very similar to the previous values reported for his cousin, that is Mustelus enle, that is reported to reside and foraging in Las Barrancas region for a longer period. So the similarity of our results in muscular tissue, that is a tissue that show that reflect time frame for the diet of the shark, like of several months and almost a year in some cases. The similarity between our results and the results of Mustelus enle for previous work indicated that also this species is foraging and reside in Las Barrancas region for a long time period. So the lack of the difference between the nitrogen levels between the other two species is also just suggesting that these other species are feeding in Las Barrancas trophy chain too, and they are sharing in some way some resources. We found statistical difference between the carbon value, particularly for the Mustelus californicus and the short-fin mako shark, which is probably due to the dimension of the shark. The Mustelus californicus were adult, so they probably can explore more deeper water and more oceanic, slightly oceanic environment where the carbon is depleted, because in Las Barrancas region there are a lot of diatomees that precipitate carbonates, and so leaving the environment depleted in carbon-13. On the other side, the short-fin mako and the cigaena, they were smaller and young of the year, so they probably concentrated themselves in shallow water. If we take a look to the metal composition, the composition is quite similar throughout all the species. We found slight difference between some tissue and some species, and the more important difference we found between the sexes of Mustelus californicus. Indeed, the males show the highest concentration of mercury. This is probably due to detoxification methodology that the females use throughout gestation, and they offload the mercury to the embryo. When we applied the isotope, the Sieber, the niche estimation, that we were able to apply this analysis just for the short-fin mako shark and for the Mustelus californicus, because for the Sphyrna cigaena we have like a small sample size, but as you can see, this is a very quite high overlap between species. Again, the Mustelus californicus show a wider niche because they are adults, so they probably can use a wider niche and explore more habitat, and as I said before. But as you can show, the nitrogen level are pretty much the same, which suggests they are feeding from similar resource, probably prey with similar isotopic composition, but for different taxas, which is also confirmed by our trophic position. We also have to say that in Las Barrancas region, that is 15 nitrogen enriched baseline, which make this, which is reflected in the nitrogen levels, and the fact that our level of nitrogen of Mustelus californicus that reside and forage there are similar to the short-fin mako shark, again confirm that they are sharing the habitat and the resource, particularly because we are using a long-term tissue. If we take a look to the same analysis but applied to the trace element component, you can see that again we have an overlap between tissue for the different species. The other overlap is between the muscular and hepatic tissue of Mustelus californicus, and this is followed by the overlap between the muscular tissue between the two species. So this overlap combined with the overlap of the stable isotopes suggests that these components are acquired through similar mechanism and precisely through similar resource, which means that they are feeding probably in similar prey with similar isotopic composition, but from different taxas. And finally, one curious thing is that, as I told before, the nitrogen levels of these two species are very similar. And the short-fin mako shark are almost all young of the year. So it's pretty much unlikely that they are migrating from other zone. So they probably born in close to Las Barrancas and start to feeding there, reflecting the nitrogen enriched baseline of this region, which means the Las Barrancas could be new parturition area for this species. Indeed, all the coast of Baja California is reported as a nursery area. But this suggests that there could be different stock which can help for future management. So finally, we found common habitat use between these species that are ecologically different, but they still can have something in common, especially in habitat that provide a lot high degree of sharing of resources, so they can share and they don't have to split. And in these cases, they probably can use a similar prey with similar isotopic composition, but not they are not forced to use exactly the same species, and this can decrease the competition. The three species showed a long-term residence and foraging in Las Barrancas, based in the nitrogen levels that we found. And finally, Las Barrancas could probably be important parturition area or a new nursery ground for short-fin mako shark. And thank you so much for your time.
Thank you, Elena. Okay, you continue with the next talk about the
moment.
About the isotope evidence for the movements of hammerhead sharks sternal connecting to natural protected areas in the Colombian Pacific. Okay.
So it's me again. But this will be shorter. Again, stabilized, but this time different species. And in this case, we will want to provide you some the results of our very short research, but that provides some interested insight and preliminary evidence for movement of hammerhead shark and the connection between two key habitats for these species in the Colombian Pacific. We know that the habitat can be used for different purposes. Different habitat can be used in different ways from different species. And one of these purposes are transition and the foraging. Transition means the moment when the shark migrates from an habitat to another. And we know that a lot of sharks can use different habitat during different moments of their life based on their need. They can use the coastal area and then migrate offshore and backwards. But in a lot of cases, for example, when they migrate from marine protected area that are focused on larger remote and offshore areas, and when they migrate from these areas to coastal area, they go outside from the marine protected area that is not longer able to offer the protection. So they are exposed to a high mortality rate. In the same way, similar way, but different, when they frequent the coastal area and they are young of the year or neonate, they can be exposed to high mortality rate due for fishery, because these areas are normally sustaining a lot of fishery, and this is very critical for long life span species, like for example the hammer shark, because the juveniles are the more ecological important stage, because they are the one that most contribute to the conservation of the population in the case of this species. So it's very critical to this is one of the challenges of the last year for the research on shark, specifically on juvenile, to identify the critical habitat, and also to identify the link and the connection between this essential habitat and how the sharks use these kind of grounds. So in our cases, we focus to the Spirna lewini. That is one of the examples of this life cycle. They frequent coastal area, they migrate offshore and backwards. And during this migration, they became very vulnerable to fishery, and they are in general vulnerable to overfishing. And despite their classification and their inclusion in CITES, we still know the technology is still lacking about the habitat use and which habitat are key for their development. So in this case, we want to focus on the trophic connectivity. We want to investigate this aspect between two marine protected areas in the Colombian Pacific, which were essential habitats for the Spirna lewini. We use again stable isotope. We had the chance to sample the 5 neonates in the marine park of Santianga, that we were sure that were neonate based on the total length and the presence of the umbilical scars. And as you can see, our results for these neonates were very, very similar in this isotopic composition to the one of adult and juveniles that aggregate in our oceanic zone of the marine protected area of Malpelo. When we apply the niche isotopic, the niche estimation, we see that there is very high overlap, that the niche rover package is estimated of the 50% of probability. And as you can see, the nitrogen levels are very similar. These nitrogen levels are probably due to the maternal transfers process. In fact, this adult could be the female adult of hammerhead shark that probably pass that pass the nitrogen signature to the neonate during gestation, which explains this similarity in nitrogen values. And the wider niche, obviously, of the adult of Malpelo is due from the migration that they can develop from the coastal areas to the aggregation of Malpelo, where they are confirmed to foraging, and then backwards to the park of Santianga. And obviously, it's different compared to neonate that have a more narrow niche. So we found our results infer that there is a significant trophic connectivity between the coastal area of the park of Santianga and the oceanic aggregation of Malpelo, which depends on shark maturity. In fact, both of ecosystems are key habitat for Spirna lewini. During different stages, the park of Santianga can be the nursery area that offers the optimal resource to these species to grow and develop until they start the migration to Malpelo, when they reside for age during adult phases. And our work is one of the first evidence of the trophic link between two marine protected areas in the Columbia Pacific, which can have a significant implication because, as I told before, it's important to identify the habitats, but also to understand the link between them. And thank you so much for your time.
Okay, thank you, Elena. The next speaker is Mayra Dilegros with the presentation about the age and growth of the Gitterite Pseudobatus glaucostigmus in Santa Rosalia, Baja California Sur, Mexico. Mayra.
Hi, can you hear me?
Yes.
Okay. Hi, my name is Mayra Dilegros. The research work I'm doing the master's degree is age and growth of Gitterite Pseudobatus glaucostigmus in Santa Rosalia, Baja California Sur, Mexico. So for introduction, razor cove in Mexico by several fisheries as target species by artisanal and industrial vessels, being an important fishing resource for the country. Because the life history of the most elasmo range provides them with a low biological productivity and the high susceptibility to become some species. It's possible that some elasmo range populations are being heavily backed by fishing. Pseudobatus glaucostigmus is one of the most common betoid species in the mandings of the artisanal fishery in Santa Rosalia, Baja California Sur. The IUCN has assessed it's vulnerable. Despite its importance, the artisanal fishery, detailed information on the life history of this species and age estimates are scarce. Studies done in Mexico for this species report a maximum length of 88.6 centimeters. The maximum age was 21 years on the East Gulf coast of California, and the beard length 17.5 centimeters, and medium mature length 52.58 centimeters. So the area of study include the localities of San Bruno, Punta Chivato, and Coloradito in Santa Rosalia. All the individuals analyzed were obtained from the artisanal fishery landings. The total length, this width of the individuals was obtained, sex was determined, and the vertebrae were collected from the abdominal cavity once the individual was caught. The neural large and soaring tissue of the vertebral centra was removed with a scalpel and soaking the structure in a 2% sodium hypochlorite solution for a time proportional to the sample size. Sagittal cuts of each vertebra were made with an isomet low-speed saw. The vertebral section were observed with a size stereo microscope and digitized. The image were observed on the reflect light and the 18X magnification, and the ground marks were counted and identified as translucent or opaque. Standard study methods for age determination were undertaken, including precision, unbiased, marginal increment analysis, age analysis, and the age verification. For preliminary results, the most with the highest frequency of sample individuals were from August to December. No samples were obtained during the closed fishing season in Mexico. A total of 210 organisms were used for age estimation, of which 206 were females, of 52 to 80 centimeters of total length, with a mean equals 66.47 centimeters, and 4 males of 52 to 58 centimeters of TL, with a mean equal 56.25 centimeters. An apparent single period of translucent band formation was observed along the year, from December to April, whereas a period of formation of the opaque bands was observed from August to November. So the largest marginal increment values were observed during August to November, whereas the lowest value were observed during December to April. The largest percent of the opaque age was observed during August to The translucent age were observed during December to April. The The annual periodicity model that the best fit the data according to the AIC suggests an annual formation of penile pairs. The age structure for females was 5 to 12 years with a mean equal 8.10 years, and for males 5 to 6 years with a mean equal 5.25 years. The following graph shows that there is not yet a fitting model, but the asymptote can be reached. For conclusion, there was a greater presence of females in the present study, probably associated with a sex segregation in the area. Previous studies have shown that the ratio is 1:1 or biased towards males. This result shows that the sex ratio in the Gulf of California could present regional change. The length and age range in previous study is wider than that observed in the present study. This change can be associated to the fishing gear used in the different localities. Thank you for everyone.
Thank you, Mayra. Okay, the next speaker, Francisco Polanco, and reproduction ecology of the long-tailed stingray, Hypanus longus, captured on the Pacific coast of Guatemala. Okay.
Okay. Can you see me? Hear me? Can you hear me?
Yes.
Yep.
Okay. Hello, everyone. My name is Francisco Polanco. Now I'm going to talk about my thesis work that is reproductive biology of the long-tailed stingray, Hypanus longus, captured in the Pacific of Guatemala. Hypanus longus is distributed from Baja California to Ecuador, but is most abundant in the southern of Mexico, the Pacific of Central America, and Colombia. This species inhabit sandy, muddy, and rocky bottoms, and it has benthic and coastal habits. Currently, this species is the most captured species already in the Pacific of Guatemala. Currently in Guatemala, there are no fisheries magnet measurements methodology. From 1 week per month, from January 2020 to February 2021, data was collected from a landing of the artisanal fishermen in a community called Zipacate in the Pacific of Guatemala. Information on the of the fishing tags was also collected. Also to characterize the reproductive aspects, the gonads of female and males were collected. Then I am going to tell you about my results. First, about the size structure. We collect information from 1,784 organisms. 825 females. The average size of the female was 84 centimeters. For males, the average size was 79 centimeters. There were no difference between size and males and females. About the sex ratio, in this case, the males are more abundant in comparison to the females. About the average size, in this case, the females reach a larger size. About the gonads, in the case of male, show development in both sides of the gonads, but the left testicle is bigger than the right. In the case for females, this species only shows development in the left side. The right side is vestigial. Also, the left ovary is bigger than the right. With a logistic regression by Walker 2005, the L50 was calculated. In the case of males, the size was 75. In the case for female, the size was 105. Finally, in the case of embryos, the average fecundity was average fecundity was 2.2. The width of size was 35 centimeters. Also, females and males, in the case of embryos, have the same average size and the same proportion of sex. About my conclusions, males are more abundant than the females, suggesting that there is segregation by sex. Average reported by this study is 2.2 embryos per female, reporting the highest fecundity in a female with 6 embryos. The main size at maturity, L50, are the smaller reported for the species in the distribution area. Thanks for that institution that helped me to develop this research, Wildlife Conservation Society, Cicimar, IPN, and Shark projects of Cicimar. Thanks.
Okay, thank you, Francisco. The next speaker is Isidoro Camarasa.
Hi.
With the maternal transfer of major and trace elements in Realizó Longurio from the Gulf of California and Baja California Sur.
Okay. Hi, everybody. I'm Mrs. and how Felipe say, I'm here to present the maternal transfer of major and trace elements in Realizó Longurio from the Gulf of California and Baja California Sur. So as you know, organisms must present essential elements as they are needed for life, but unfortunately, they can present non-essential elements and can cause health damage even in low concentrations. In this study, I work with a pregnant female of Realizó Longurio and its embryos, and I analyze the muscle and the liver of all the individuals. I want to say that the embryos were really, really small, and as the species is placental viviparous, they were still feeding on yolk sulk, all the embryos. So for the essential trace elements, I analyzed 13 different essential trace elements, and all major and trace elements were all transferred. So we had quantifiable concentration in the pregnant female tissues and embryo tissues. For the non-essential trace elements, which I analyzed 11 different non-essential trace elements, we found that most of them were transferred to the embryos. So there were quantifiable concentrations to the pregnant female tissues and embryo tissues. But for tin, antimony, and lead, we had that there were quantifiable concentrations in the pregnant female tissues, but not to the embryos. So in this study, for these 3 non-essential trace elements, we cannot say that exists transference of these elements. A few examples of non-essential trace elements that I analyzed, and we find here arsenic. Arsenic has really high concentrations in pregnant female tissues and embryos too. And this could be due to two reasons. The pregnant female was fished around a mining region in Santa Rosalia, Baja California Sur. And this could be one reason. And the other reason can be due to the capture of the female was near an area that has a high activity, hydrothermal activity. And there are already studies of this area in sediments, and they found that it was really high in arsenic too. For example, strontium, here we can find that the embryo had higher concentration of strontium than the pregnant female. And strontium is really similar to calcium, and they blind in the same spots. And this can cause competition, and it can cause hypocalcemia to the individual. For example, for cadmium, what we found is that the pregnant female had really high concentrations in its liver, but if we can see the concentration in embryo were really, really low. So it is transparent because we found quantifiable concentration in the embryo tissues, but not really in a good rate compared to the liver tissues of the pregnant female. And the other non-essential trace element is silver. Here it was unexpected because we found that the pregnant female had really, really low concentration in muscle and liver tissues. But if you can see here, the liver tissue of the embryo compared with the concentration of the pregnant female was really high. And if we see the literature, we found that in Narcina brasiliensis, they found a similar pattern that in embryos, they analyzed different organs of the embryos, and they found that the liver had the highest concentration too. And here I want you to show you that of the 11 non-essential trace elements analyzed, 4 of them, embryos had higher concentration than the pregnant female tissues. And here we can see how the maternal transfer process can work as a detoxification way for the pregnant female. So easy conclusions, like here we have that all essential elements were transferred during gestation as we expected. And for non-essential elements, we found that tin, antimony, and lead were below detection limits in embryo tissues, and the remaining non-essential elements were actively transferred. And thank you.
Okay, thank you, Isis. Okay, the last speaker is Jorge Felix Pintueles Tamayo with the bioaccumulation and biomagnification of trace elements in the ray Pseudobatus glaucostigmus in the Santa Rosalia area, Mexico.
Hello.
Pon la pantalla completa.
Okay, hello everyone. Let me introduce myself. My name is Jorge Felix Pintueles. I am a PhD student at the Interdisciplinary Center of Marine Sciences. Now I'm going to present my research project in bioaccumulation and biomagnification of trace elements in the ray Pseudobatus glaucostigmus in the Santa Rosalia area, Mexico. Well, the vast majority of trace elements are essential nutrients as they perform numerous life-sustaining functions, while others have no known biological function and are therefore toxic to organisms in inadequate concentrations. These elements can be released by mobilization process, volcanic activity, and rock erosion. In addition, due to human activity in industrial process, metallurgy, and mining activities. Many of these elements are considered heavy metals and have a great impact on marine ecosystems due to their viability, potential reactivity, high toxicity, and bioaccumulation. Bioaccumulation process occurs when the intake on the toxic element exceeds its capacity to be excreted. They are transferred from a lower to a higher trophic level, increasing their concentration through the trophic webs. Therefore, higher concentrations will be found in predators compared to their prey. Within this group are the bathoids and cartilaginous fish that are known as benthic predators. In particular, our target species is Pseudobathus leucostigmus. This species differs from the genus by the presence of blue spots on the head around the eyes. Several studies describe the importance of the ray fishery in the Gulf of California, where this species has been reported in the first places of landings. Santa Rosalia, located on the central eastern coast of Baja California Sur, has fishing landings of this species. At the same time, has been a point of reference for different authors who point out contamination in the area. Trace elements values have been documented for several species in the region that exceed the permissible limits of Mexican standards and those of other countries. For these reasons, the purpose of this work is to determine the bioaccumulation and biomagnification of mercury, cadmium, copper, and selenium in the muscle and hepatic tissue of the spotted guitarfish Pseudobathus leucostigmus in Santa Rosalia, Baja California Sur, Mexico. Well, the study was carried out in Santa Rosalia area in 3 coastal locations. Samplings was conducted during 2019. Gill nets were used to capture the fish, and each organism was registered for weight, total length, disc width, and sex was determined from the presence of Goronteridium. Stomach, muscle, and liver samples were taken. The main prey of the species were identified from the stomach contents. Muscle and liver samples were freeze-dried for 24 and 48 hours. Then it were homogenized using an agatha mortar, and the material is currently being prepared for the digestion of the organic matter and the reading of the concentrations of the elements. Sorry. As preliminary results, we have that the relative importance index showed that Peneus californiensis is the most important prey in the diet of Pseudobathus leucostigmus. And we have, as expected outcomes, estimation of mercury, copper, cadmium, and selenium concentration in muscle and hepatic tissues, relationship of concentration with size and sex, mercury and selenium molar ratio, and estimation of the weekly intake rate of mercury and cadmium to assess the potential risk to human health. Well, last but not least, I would like to thank my teammates at the Institute and the other participant institutions, and thanks for your attention.
Okay. Well, we are open for questions to all the speakers, and then any question for some of them. I don't see any hands. No questions. Okay. Well, Sean.
You. Yeah, thank you, Felipe, and all the speakers. It was really interesting session. And last chance for any questions for the group. We are at the end of the first day of the Northeast Pacific Shark Symposium. It's been really great. I want to thank all of the speakers and moderators and thank all the attendees. Some reminders for tomorrow. We will start at 12 p.m. Pacific Daylight Time, so the same time as we started today. You will use the same Zoom link that you used today to join. And unless there are any other questions or comments, I think we are done for the first day. And there we go. And have a great evening. We will leave the chat on for about 15 minutes. So if you want to chat to anybody, you can do so. If not, we will see you all tomorrow. Thank you.